Hello everybody, this is Carmelo Pinzoni with another exciting video on changing a repeating decimal into a fraction. So this is more of an intermediate level for some of my students who are taking college level courses out here at the College of Southern Nevada, or where else you may be taking classes that require you to change a repeating decimal into a fraction. All right, why don't we get started? Today is September 9th, 2025. And let's go on and show you the basics of changing a repeating decimal into a fraction. And we're also going to use the TI-30XS calculator, which I already have online there. And hopefully everybody in my class or beyond has this kind of calculator. It's a very useful and powerful tool you can use for your tests and for your different classes you may be taking out there. Okay, so let's say we're dealing with a repeating decimal. Let's say we have something like this, 0.181818. And if there's dots like this, it means it's repeating in that sequence, 18181818. How are we going to change this into a fraction? So this is what we're going to do. We're going to take the two digits which end the repeating cycle, and we're going to bring them down without the decimal. So we're going to write down 18. And then what you're going to do in the denominator is you're going to write down nines. If there's 1 and an 8, there's two digits. We're going to write the nines twice, just like that. See, it's different than putting a 1 underneath. In my last video, when you have a terminating decimal, you put a 1 underneath. And I'm going to let you go ahead and review that video of mine where the decimal terminates. You're going to put a 1 underneath and then move the decimal point, and you end up with getting the fraction. Here, it's a little different. So here I have a repeating decimal of 1818. So we're going to write down 18, and then we're going to write down 99. So the only thing last I got to do is reduce this to lowest terms. I'm going to show this on paper and pencil what to do, and then I'll show you on a calculator what's going to end up happening. So you want to find the greatest division number that will work. Let's try the 9. I know 9 works on an 18, and of course 9 works on 99. You want to make sure that this number will divide both numbers evenly. 18 divided by 9 is 2, and 99 divided by 9 is 11. 11 times 9 is 99. So that's the final answer on this one here. It's 2 over 11. So this is an example of a repeating decimal and a fraction. This will happen in a lot of more moderate studies that you may be taking out there in college work, and you may have to take a decimal and turn it into what they call a usable fraction for various reasons. So I can also call this, I'm going to say 2 out of 11 students were sick that day. So the decimal equivalent is 0.181818. Repeating decimal students were sick that day. So let's go ahead and take a look at a decimal that does terminate here. And this is going to be a little bit of review from my last video. Let's say it's 0.18 without the repeating. Now, before we move on any further, when we compare these two decimals, are they equal? They're not equal. They're a little different. See, the repeating decimal has all these 181818, so that tells me this is the larger of the two. It's larger by a fingernail. Because if you think about it, if you remember it in my basic elementary classes, if you put zeros to the right here to see and to size up decimals, you can put zeros here. It doesn't hurt the value. But of course, 0.18 and all the zeros is going to be smaller than 0.18, 0.18181818, right? So 0.18 repeating, this is the repeating bar I'm going to put above it, is greater than 0.18 itself. It's just by a smidgen, by a fingernail. That's it. But nonetheless, it is greater. And in the world of mathematics, this does make a difference. So whenever we're doing different calculations of business world, medical care, whatever it is here, we got to make sure we are using the right decimals and the right fractions whenever we're calculating things. If it's 2 over 11, I cannot use 0.18. That's a different fraction. We're going to see that in a minute. 2/11 belongs with the repeating decimal, 181818. Okay. So now 2/11 is going to be greater than the futuristic fraction I'm going to get from here. Okay. Remember on our last video? Put it over 1. This is a terminating decimal. Put it over 1. You're going to move the decimal point 2 places to the right to make it a whole number. Put the decimal point behind the 1 and move that also 2 places. What you do on the top, you got to do on the bottom. Put 2 zeros here. And now let's write this down here, 18 over 100. Paper and pencil action. I'm very blessed. I went to school back in the 80s and the 90s. This is the stuff we had to do back in high school and in college. We didn't have calculators like this. So now what we have here is 18 over 100. Now you have to find a common division number to reduce this. Obviously, if both these numbers are even, at least a 2 can be divided into both of them. Is there something better? 4 is not going to work. 6 is not going to work. 9 is not going to work. It looks like it's the 2. So here we go. We're going to divide by 2 both parts here. This is 9 over 50. And that's as far as you can go, because for the 9, it's the 3 or the 9 itself, and the 3 or the 9 does not divide into 50. So we're done. So you can see and appreciate that a little change in a decimal changes the fraction a little bit. So in this case here, 9 out of 50 students were sick today. 0.18 students were sick today. For this one here, like I said, 2 out of 11 students were sick that day. 0.18181818 students were sick that day. So this is a little paper action here on this particular repeating decimal. And we're going to check that in a minute on the calculator. It's going to be right. There's nothing else that's going to be different about it. Just verify it myself to make sure it's right. It is right. And we're going to check it on the calculator up on the screen in a minute. Let's do another one. So remember, repeating decimals gets the 9 treatment. Terminating decimals gets the 1 treatment. That's what you got to remember in paper and pencil. Let's take a look at another one. In this fraction, decimal is more common. Let's say you got 0.1 and it's a repeating decimal. So that means there's 1, 1, 1 here, right? Whenever you see the bar on top like that. So again, remove the decimal point, bring down the 1, because that's the only digit that's existing there, right? So we're going to put the 1 there and put it over 9. That's it. That's the final answer. Can't be reduced any further. Now let's take a look at the common decimal that terminates 0.1. So see, repeating decimal, larger. It's 2 fingernails bigger than 0.1 terminating. Let's do this as a fraction. So we can say this inequality is correct. 0.1 repeating is greater than 0.1 terminating, right? So we have the fraction here, 1/9. Let's make this into a fraction. It's terminating, put it over 1. One place to the right, one place to the right, put a 0 here. At the end of the day on this one, it's 1/10. So see, now you can start appreciating repeating decimals have a larger value. In this case, 1/9 is larger than 1/10. 1 out of 9 students were sick that day. 0.11111 students were sick that day. Or I could say 1 out of 10 students were sick that day. 0.1 students were sick that day. What do you think of those bananas and peaches, everybody? Like that? So this is how it works in the intermediate level with these repeating decimals. Okay, let's take it a step further, and let's say we have a whole number in front. Let's say we have 5.16, and then we're going to kind of do this here. That tells me it's repeating. We want to make this into a fraction. 5.16. Well, 0.16, let's forget about the 5. We're going to set that 5 aside. Let's forget about this for now. Leave it over here for now. We're going to look at 0.16 repeating. Now, that's not a common fraction that's common to us. So 0.16, right, it's 16, etc., right? So what we're going to do is we're going to bring down the 16 without the decimal point, and we're going to put it over 99. Now, we want to see if this is in lowest terms. You could use your calculator, of course, but I can look at this and tell you out of the gate, this is as far as I can go, because what works with 16 is 2, 4, 8, and 16 itself. These are the division numbers that I look at here that I was taught years ago what to do and formulated my own plan of how to divide these out. None of these are going to divide 99. So there's nothing there. This is an odd number. You got an even number. It's not going to work. So that's it on a fraction. Now what you want to do is you want to bring that 5 down into play here. Now you got a mixed number or mixed fraction, however you want to call it. They called it a mixed number in my day, and I like to call it as a mixed number. So what we want to do is we still want to turn this into a fraction. This is going to turn what they call an improper fraction. Okay? Improper fraction. All right. Improper fractions are valued at 1 or greater. We have a mixed number here with 5 and a little bit. So it's an improper fraction. Top number will be larger than the bottom number. Okay, in order to do this, you could use your calculator, but we're going to do this in the old school way. 99, we're going to multiply with the 5 and get the product. Once we have the product, we're going to add the product to whatever's in the numerator, and we're just going to put that numerator over 99. Five times 99, I don't know, 495? 5 times 99, yeah, 495. We're going to add 16 to that. 511. So you may have to use a fraction equivalent for a decimal with a whole number in front. So change the repeating decimal into a fraction using the 9s. And then we can bring down the whole number and use the multiplication addition technique from back in the day. Then we'll have a numerator. That's it on that one. I like that one, how that turned out. All right, let's try another one here with another repeating decimal. Let's say we have, I don't know. Actually, we're going to go ahead and take a look at 5.16 in the calculator a little later on. We're just going to leave it up there so I remember it. 7.123 and repeats, okay? So it's 1, 2, 3, etc. Okay, leave the 7 aside. That's going to come into play later. Bring down 1, 2, 3 without the decimal place. Since there's 3 digits before the next series begins, 999. All right, how to reduce this bad boy, I'm going to call it here. Well, there's a trick here. How do you know if a number is divisible by 3? Add the digits, you get 6. If the summation is divisible by 3, then the whole number is divisible by 3. So I can use 3 to start. And again, paper and pencil, this is what we had to do back then. But nonetheless, you may have to do that. Maybe you're in a class where calculators are prohibited for whatever reason. I don't know why, but nonetheless, maybe there are students out there who are in grammar school, middle school, whatever it is here. This is the way it was taught. Okay, I can tell you right now downstairs is 333. 3 into 123, well, let's see if we can do this like this. 4 times 3 is 12. 0, bring down the 3, it's 41. All right, 41 over 333. Well, 41 is a prime number, meaning that only 1 and 41 are divisible. And 4 plus 1 is 5. There's no 3's involved. That's it. And we also can check these on a calculator too in these days, but back in the day we couldn't check them. We had to figure out ourselves. But 41 will not go into 333. At least I don't think so. Let me just double check that before we move forward. It does not. So 41 can't divide out 333 evenly. That's the fraction. Now what you want to do is this. Bring down the fraction. Bring down that 7. We're going to turn this into an improper fraction by multiplying 333 by 7 and then add the product to the 41. And then we'll have a top number, which will be much larger than the bottom number. We're going to bring that 333 across. These match. 7 times 333 equals 2331 plus 41, 2372. And there's the equivalent fraction of 7.123. There you go. Again, any questions, please place remarks in my YouTube page there on the video, and we'll answer those questions in case of something went wrong. Okay, let's go back to the calculator. We're done with the paper and pencil. Hopefully you got a nice little lesson in understanding how things were done on paper and pencil back in my day. Let's go ahead and take a look at the calculator now. I'm going to mess around with that for a little bit and take it from there. Okay, do you remember the 41 over 333? I said it couldn't be reduced any further. Now we can check these. 41 ND 333. Enter. That's as far as you can go on that. Now, if you forget to remember the nines technique, remember that 0.1616, you got to put in enough of the repeating decimal in order to yield a fraction. So that's what, 16 over 999. Let's see what happens if it comes out to that. There's your 16 over 999. So if you forget to do the nine treatment, put in enough of the repeating decimals in the calculator and then hit your switcheroo button. Don't do this. See, again, you're terminating the decimal, you're going to get an incorrect fraction. You're going to get 4 over 25 for that. And again, you got to put enough in it. This is still not enough. Let's see what happens with this. See, it can't recognize it. So you got to make sure you put in enough. Usually you got to fill the display. Fill the whole display. And then you'll see where it's what they call converging to. It's converging to 16 over 99, and that's it. And then what do we have? Was it 5 and 16 over 99? We needed that fraction out of it there. There's a way to do that. So 5, I need the second key to put in a mixed number, 16 ND 99. Okay, there's a way to second, and then you need this key here. If you look above, whenever you press the second key, you activate the lime green functions of the calculator. 511 over 99. Is that what we got earlier? So this is how you toggle on a calculator. There's a lot to learn on a calculator that we do in our classes, and hopefully this will help us out here. It's very good. But you got to make sure if it's a repeating decimal that you got to put the entire sequence into the display here. You cannot cut decimals off, or else you're going to run into errors in your papers and your report writings and whatnot there. All right there. This will conclude this video on intermediate decimal fractions. When the decimal is a repeating decimal, we're going to use the 99 treatment. Reduce the fraction, and if you got a mixed number, you bring that whole number into the mix. Denominator multiplied by the whole number gives you a product, and then take the product, add it to the numerator, and then you put the numerator on top of the denominator that you're working with, and that's your final answer. All right there. This video is now ended here. If you like what's going on here, please subscribe to my channel. I have more math videos in the future. Otherwise, looking forward to the comments and any remarks that you may have out there. Otherwise, have yourself a nice day, and we'll have another video in the near future. Have a good day. Bye-bye.